Alright, the recorder is on, the mic is active, so I am actually recording. So let's go ahead and go to the class. You don't have to do that with your own computer. We are pretty much done with getting started, so all of that stuff is out of the way, and we can now actually start to write some programs. The second homework assignment, since I have not given you, the code, the template code to print Hello World, you cannot really get started on that one just yet, and that's what we'll do first. First thing today is to write our very first program, compile it, and then run it. Okay, so that's what we'll do first. To do that, what you need is to use a terminal, otherwise known as a CLI, a command line interface. You can choose whatever editor you want to use. There are two editors built into the Linux virtual machine that I distributed to you guys. One is called VI or Vim. The other one is called Nano. Nano is easier to learn because it has kind of like the help is at the bottom of the screen, so it's easier to learn. In the long run, however, VI is the one that you might want to learn. So if you're a math major or engineering major, and cisp360 is a high level of a class you need to take, and you don't really plan on using Linux, much more after this, Nano is probably a better choice. On the other hand, if you are in computer science, or you think that you might want to use Linux, kind of in a longer term, then learning VI or investing the time to learn VI, may not be a waste of time. Okay, I personally learned how to use VI, and the thing about VI is the first time you learn to use it is really hard, but after a while it becomes not only second nature, it's muscle memory. Okay, if someone is to ask me, okay, how do you do blah blah blah, I can't really say it until I actually do it on the keyboard. Then I can watch myself do it on the keyboard and then say, okay, this is how you do that. So it's kind of interesting. Yep.
To follow along with you, would we have needed to install the VM Linux and have it either on a USB drive for this computer or have it on our own laptop to follow along with what you're doing?
You don't have to follow along right now because it's all getting recorded. So you can actually watch this again, when you're ready to do your homework. The program itself is pretty simple. Okay, it's called Hello World. If you just Google for Hello World, that's you can copy and paste for the most part what I'm doing. It's the steps that are important. You do need your virtual machine to do your homework, or you need access to a Linux type computer to do it. Okay. All right. So the first thing we'll do is I'm going to take a look at the homework description itself, because I don't want to not follow my own instruction. So you need to follow the instructions exactly in order to get credit for this homework assignment. In other words, if something is turned in but is not exactly what I want, that particular homework assignment will receive no points. Yes, it is an ouch, but it's not really a big ouch, because the proportion of points for this homework assignment and also for the the other one that is due on Wednesday, they're really small point value homework assignments. So the whole idea is to get you guys into the habit of running the commands correctly in exactly the way I want it. All right, so we'll just go ahead and read the homework assignment. For this assignment, all files must be in a single folder named World. And you can see world is spelled W-O-R-L-D, all lowercase. So that means it cannot be first letter uppercase, cannot be, cannot have a typo mistake, cannot be Wayne's World. It has to be exactly spelled that way. Okay? The file containing the source code must be main.cpp. Once again, main.cpp, all lowercase, cannot be uppercase main.cpp, cannot be main.c++, okay, using the actual simple plus. It has to be CPP. Use the example I wrote, the one that uses printf in class, which I'm going to do, okay, so that's why there's a demonstration as an example. But your program should print the following. So instead of printing Hello World, it has to print your first name, whatever your first name is, apostrophe S, world rocks. Okay, replace first name with your first actual first name. In other words, my submission should print the following: Tax World Rocks. Okay. To turn in your homework assignment, we have a very similar command compared to the one that you have to do for the other homework assignment. So once again, I'm going to point out the not so obvious stuff. Okay. Spaces are all important. Second thing, uppercase C. That's not a lowercase c. It has to be uppercase. This is a forward slash. It's not a backslash. And these are back ticks or back quotes. Okay. So you have to observe all of these little details in order for your homework to be graded. When you run the command, you have to be, the working directory has to be world. Okay, so you have to remember to do that. Upload this particular file to Moodle, because the previous command, the tar command, is going to create this particular file, and that's what you need to turn in to Moodle. Okay. You have to use WinSCP. I showed you guys how to use WinSCP the other day already, so that part is all done. So let's go ahead and do this homework assignment. So I'm going to do it myself here. So the first thing is, how do we create a folder so that it, yep, go ahead. Question? No, okay. So the first thing we need to do is to create a folder, and the folder has to be named exactly world. Okay, do you guys have any questions back there? No? Yes, go ahead.
It was homework that we have to do next class. Let's do next class.
This is going to be due in a week.
Yeah. Is it okay if it's about the other one you were talking about before?
That one is, you want to talk about that one?
Well, that's the question. That's what it was.
You have a question regarding that one? Okay. All right. Yep, go ahead.
Is the lab that you're showing us is Your World Rocks?
Yes.
That says it's due on Wednesday, not a week from now.
I will have to change it because I haven't really talked about this program yet, so it's going to be due a week from today. Okay. Alrighty. Okay, are you guys good back there? Okay. If you have any questions, direct the questions to me and not talk among yourselves, please. Thank you. All right. So, how do we create a folder? Because you need to create a folder called world first, okay, and put the file main.cpp in it. In Linux, to create a folder is mkdir. You can do this in WinSCP. So WinSCP allows you to do most file operations using the GUI interface. So you can use it, but I find it just easier to use the command line here. mkdir is make directory. And what is the name of the folder that I need to make? World, okay. Can it be this? Well, what if I press the enter key already? You can rename it, okay? So for those of you who might make mistakes when you're typing, it's okay. You can rename a folder after it is created. The command to rename a folder or a file, or to copy something, not to copy, but to move a file from one place to another place is move. But move is not MOVE, it is MV, okay? It's just MV, moving from, moving to, okay? So in this case, move is a misnomer. It's not actually moving a directory. All it is doing is to rename a folder from uppercase W world to lowercase w world. Press the enter key. That's it. Okay. You guys, do you have any questions? You guys have any questions back there? No? Okay. All right. So, in order to change your working directory inside this newly created folder, you have to use CD, which stands for change directory. Now, this is a concept that you have to remember when you're using a CLI. It does not really quite exist. Well, I guess it does with GUIs, but with a CLI or with a command line interface, you always have a current working directory. In other words, where are you standing? What is the reference point at this point? Okay. By using CD, you are changing the working directory. and you can change it to anything. You can specify, anything here, as long as that directory exists. But in this case, I'm not interested in everything else. I'm only interested in the folder that I just created, which is world. So cd world is going to change the working directory into the folder that I just created. The confirmation that you did this correctly is the prompt itself. You can see the prompt is also printing the current working directory path. Yep.
What's the MV command?
It's move. It renames a file. Now, what if you cannot remember these commands and what they do? Man comes to the rescue. Man stands for manual. Okay, so you say man mv, and it shows you this is a move in parentheses rename files, and those are the options. Okay, so this is a really useful thing in Linux. Almost every single Linux environment has at least the basic man pages. Okay, you can use page up, page down inside here. Okay, so page up, page down will work. You can even search. Okay, if you're searching for a particular thing, press the / key, and then type what you're searching for. Okay, so if I'm looking for recursion, okay, recursive, or just recur, well, it doesn't have that. What directory? Okay, so you can remove a whole directory, or you can move an entire directory from one place to another place, or you can move something into a directory. So it's a really useful command. What if this is not enough? What if you read the man page and it's not really telling you exactly what to do, or it doesn't give you some examples that you want to use? You can contact me. I will try to answer those questions, but it might be quicker to use Google, right? So you use Google and you search for mv command examples, okay, or tutorial, or whatever you want to use. And yes.
Are these commands the same for all Linux, or just for this?
The commands that we use are universal, at least to all Linux distributions. If you have Mac OS X, most of it will be the same as well. Okay, so Mac OS X is Unix-based, which is not exactly Linux, but they're closely related. So a lot of the commands that we use in this class, they will also work in Mac OS X in the terminal. That's a good question. So there we go. Well, I guess it's the same page. So if you want to look for tutorial, I suppose if you spell out tutorial, that will make it more of a tutorial. There you go. All right. Are there any questions about the move command, mv? Okay. Do you want to use a chair, because we still have some additional chairs here? Because otherwise you'll be standing for an hour. You don't want to do it unless you have to. In elementary school and high school, I got sent back to the classroom and stand a lot. So I kind of understand it. And that had nothing to do with running out of seats in the classroom either. Alrighty, so getting back to the homework. Alright, so the next thing we have to do is to create the file and also edit it at the same time. Remember what I said? There are 2 editors already installed in the Linux environment. Now, if you use WinSCP, you can quote-unquote cheat a little bit, okay? Because you can actually create a file and use a notepad type editor in Windows, even though the file is quote-unquote saved in Linux. So you can do it, but it's kind of like a shortcut. By doing that, you won't be learning how to do it inside a native Linux environment. Yes?
If you were to do it the way that you were explaining, would you use the file transfer program that you showed us last
Right.
class?
Yeah, WinSCP, if you look through the options, there's one that says create a file, but if you click on a text file, you can actually edit it, inside the text editor.
It would edit it?
Yeah.
Okay.
Yeah, so it's kind of like a shortcut, if you don't want to
you have
learn.
to review it afterwards, make sure what it is.
Yeah, it's when you save it, it is not really saved per se in Windows. It is actually transferred back to the Linux virtual machine.
Okay. So you just gotta double check it.
Right. Yeah. But I would just go ahead and use VI here. Okay, VI is my favorite editor. It doesn't have to be yours. Okay, so once again, you have choices here. Okay, so we're going to type up this program, and I will also turn on line number. Okay. And I will also briefly explain this program a little bit. And I'm not going to do this correctly, so I will get some points deducted if I turn this in. But what I'll do is I'm going to explain this program a little bit. Yes? I use VI. You can use Nano if you want to. Okay. And I forgot to give it a file name. So when I save a file and want to specify the file name, I use W, which stands for write, and then main.cpp is the name of the file that I want to save to. Okay. Press the Enter key. It says it exists already. Alrighty. Might be in the wrong folder. No, I am in the right folder. Oh, that's because I already had this folder before from the previous semester. Let me just redo this again. If you want to remove a folder, you have to use the -RF option to recursively delete the content of a folder. Or you can use WinSCP to delete a folder. That will work as well. But I'm going to repeat all the commands. Make dir world cd into the folder. Now it is all empty. ls is kind of like dir in DOS. It lists the content of the current working directory. Okay, and now I can use my command vi, and I supply the name main.cpp. So let me just retype the whole thing. All right. So we have a fairly simple program. It's a 7-line program. Other than the first line, everything else from the second line all the way to line 7, all that content can go to one single line, and the C compiler does not care. Okay? Alrighty. So instead of explaining the syntax of C, I'm just going to say, well, to you, does it make any sense? I mean, can you at least read a part of it?
Why do you have a return?
Because the function has an integer return type, so you have to return a value. If you do not specify a return on line 6 here, the compiler would actually give you a warning if you turn on that optional warning. Yep.
Have to be like a number like 0 or
Whatever value you specify becomes the actual return, the exit code of the program, which is significant in some cases. So most programs should exit or return with a value of 0. Yes?
Just having a get here function keep the loaded. What was the command for flushing standard buffer?
Standard buffer?
Not standard buffer, rather. That flush for just bump the.
You don't need to flush anything. This will automatically do it. When the program exits, it will automatically flush.
What about just to have so I can flush it, then use get card to keep it open rather than having just close.
I don't think this is going to be an issue in this program. Alrighty. Are there any questions? Yes?
Do we have to set the Linux read on this?
Yes, you have to work on this inside the Linux environment. Now, some of you may be able to do this without a Linux environment, but when I check it, I would be assuming that you did it inside the Linux environment. So if there's discrepancy of any kind, then you won't be able to get points for this particular homework. Yes?
Print f, the command, is it the same like as cout?
It's similar to a cout here, but I'm just using printf here. Okay? And the double quotes, the content inside the double quote is what is actually getting printed. Okay? So that should give you a pretty good clue of how to edit this program to fulfill the requirements of your homework assignment. Yes?
So after world, the exclamation point \n is just nonsense.
No, it's not nonsense, because the \n is basically what we call a new line character. This is how you separate a line from the previous one, is the new line character. If I do not specify the \n, then the command prompt will be printed right next to hello world exclamation point, because there's no new line to separate the output of this program and the command prompt itself. Yeah, and you can try it out too. I mean, this kind of program, you can just kind of play around with it a little bit. Yep.
How do you get the line numbers to come up?
In VI, if you want to turn on line numbers, you have to press the colon key that will get you onto the command line, part of your VI, and then you say, set SET-NU to turn on line numbers. There are other options as well. Okay, you can turn on syntax highlighting, for instance, and I think that one is syn on, SYN space on, and you can turn on syntax highlighting. I don't use syntax highlighting in class because you can see that with syntax highlighting it's actually harder to read because the font, the color is too dark. All right. Are there any questions about this program? Okay. What about these words? Include, printf. Does printf suggest to you, someone who may not know the printf function, that it is for printing something? It makes sense, right? The open and the close curly brace, even though you may not know the syntax of C, but you probably can guess open curly brace is matched by the closed curly brace to become a unit of some kind, right? It makes sense to you. Do you think this program makes sense to the processor, the i7 processor inside this box?
No.
No, it does not make sense at all because
It doesn't speak that language.
a processor does not understand this language. Exactly. So what kind of language do you think a processor understands? Binary code and assembly code is actually one step on top of a machine code. So let me just give you an idea of what kind of code your processor natively understands. So all you have to do is to look for Intel x86 machine code, okay? And obviously there are many documents for this one. I'm just looking for one example, so just bear with me. This one doesn't include the details. I'm just looking for one. This is a good one. There we go. All right. So these are the machine code. I can't really, let me magnify a little bit. I can do that at least. Okay. So on one side, in terms of bytes here, that's the actual machine code. What is the base used in this case? I'll give you a few choices. Is it base 2, base 8, base 10, or base 16? It's all base 16. How do you know it's base 16? Because the use of the A to F, right? So in this case, we'll take a look at this one here. We're adding a byte, indirect. It's you guys will see all this again in cisp360. But basically, this part specifies. Okay, this is the source and that's the destination. It's a register to a certain memory location. And it's an add instruction, which means it is taking 2 bytes, added together, and then store the result into the destination location. That's assembly code, okay? This is something for us to read, okay? It makes sense to us because we understand the word add. We understand the word byte, we understand the word PTR, which is pointer, and so on. But when the processor needs to execute this instruction, the actual code to the processor is 0081F705. That's the hexadecimal number representing the bytes that the processor, the i7 processor, actually has to process to perform this operation. The processor does not really natively understand hexadecimal numbers either. It only understands what? Binary numbers, right? Zeros and ones. So we are talking about a really long string of zeros and ones here. We're talking about 0000, 0000, 1010, 0001, 1111, 0111, 0000, and 0101. That is the actual string of zeros and ones that the processor understands and goes, oh, so you want me to add this register to that memory location. Got it. Do you want to program your computer using those binary numbers?
No.
Well, guess what? In the early days of computer science, that's the only thing people have in order to write programs. They don't even type the zeros and ones. They have to flip switches. Okay, flip up is a 1, flip down is a 0, and that's how they program memory locations in the computer. Yep.
What's the syntax for the
The syntax? You mean for this part here?
Yeah, just kind of like, because I'm looking at it like to add and divide and stuff like that. There's supposed to be a pattern for a syntax.
That part is called a mnemonic. Okay, this is called a mnemonic, which is a very easy, well, not very easy, but it's an easier to understand representation of the instruction. In other words, would you rather deal with the hexadecimal numbers or binary numbers, or would you rather have to deal with the other part? Well, the right-hand side is easier because it's called a mnemonic. It's basically using a somewhat human-friendly language to describe the operation.
I guess what I'm trying to ask is like, so does the mnemonic?
There's a
say you-
syntax.
Okay, yeah, but like, so say you have add, does that correspond to a hexadecimal number, and then that number gets translated to binary?
No.
Or does the
Mm-mm.
mnemonic get translated to binary,
No.
and then
No.
the hex represents the binary?
An assembler would actually take the description in assembly language and translate that into the machine code. So to go that step, you actually need a program to do it. That's all in CISP 310. So by the time we get to CISP 310, that will definitely be explained more, in more completeness. But for today, I just want to show you, if you want to program in the native language that your processor understands, you'll be dealing with a lot of zeros and ones. Okay, what if you miss one of those zeros and ones? What if the correct code is a 0 and you put in a 1 instead? Yep, exactly. And nobody's going to warn you. Nothing is going to warn you and go like, I think that's wrong. Okay, nobody's going to, nothing, no tool is going to warn you except your processor will just take it in and try to execute the instruction as it is specified. Okay, that is not a very good way of programming computers. Okay. So going from this back to our sample program, that seems a lot easier to understand compared to a whole bunch of zeros and ones, right? But unfortunately, even though it's easy for you to understand, the processor has absolutely no idea what this means, because the processor can only deal with the zeros and ones. This is much more human-friendly. It's called a high-level programming language because it is easier for people to understand, but it is very difficult for computers to understand. So what do we need is a translator, okay? We need a translator to translate main.cpp, which is a text file, into object code, okay? That's the first step we have to do. The first process that we have to do is to compile the program. To compile the program, we have a command line program called G++, and in this case, G++ is actually using the plus symbol. And what you need to do is to specify some options. And I'll tell you what each option does, and because they all do something that is useful. And some of these are optional, but I will explain all of them. Okay. So this is a fairly long command line, but once you know what it does, you won't forget it. G++ is the name of the command. -G means I want to include debug information. In other words, I want to be able to run this program inside the debugger later on so I can debug this program. Now, obviously, in this particular case, what is there to debug? I mean, this program is really simple. But that's okay. We'll just have a habit of using a -G. -WALL with an uppercase W means warn all. Okay? It tells the compiler to be extra naggy. It's like, if you spot anything that might be wrong, tell me about it. Okay? Most people forget the warn all, or they intentionally turn it off. Okay, do not turn it off. Make sure you specify warn all, because if the compiler spots anything that is suspicious, most of the time it is suspicious or wrong. Okay, very seldom it is something that, oh yeah, I intended to do that. If you do intend to do something that is being warned about, you can always, there's always a way to circumvent, the warning message. Pedantic is not really important in this class. You can kind of forget about this one if you don't want to. But in industry, this is important because it makes sure that G++ is only going to use NCC standard when it's compiling this program, because there are extensions to G++ that is not in the ANSI standard. Okay? -C means I just want to compile. Don't do anything else. Just compile, translate the source file. Okay, main.cpp is called the source file. Stuff that you can easily understand and read is called a source file. Just compile it. Don't do anything else with this file. So that's a -C. Are we still doing okay so far with this command? Okay, if it's okay, we'll go ahead and press the enter key. It won't take long because it's a really short program. But what I do want to show you, oh, by the way, what is ls? What did it do? It lists the content of a folder directory. So we have a new file, okay? This is the source file. This is what I created using VI. But now we have a new file. It's called main.o. .o means it's an object file, okay? O for object. Object file means it is translated already. It is actually in quote-unquote machine language. But I cannot run this file, okay? There's a reason why we can compile, but we can't really run the object file just yet. It has to do with how many source files do you need to write a program, okay? That's the question. How many source files do you need to write a program? Now, obviously, in this case, 1, right? That's the entire program. What about Linux as an operating system? Do you think people write the entire Linux operating system in one single source file? Why not? How big?
Pretty big.
Pretty big. Let's find out, okay? Let's Google, right? Lines of code Linux. How many lines of code are in the Linux kernel? And this is just the kernel itself. And the answer on, okay, what is the date of the answer? Because this is actually important. Last asked was September 3rd, 2011, so that's 4 years ago. So 4 years ago, it was 10 million lines of code. And that's not including comments. 10 million lines of code. Can you imagine putting 10 million lines of code into one single file? So every time you want to make any changes, you have to bring in 10 million lines of code. And every time you save, you have to save 10 million lines of code. Every time you compile how many lines? 10 million lines of code. Are you changing all 10 million lines of code each time? How many lines do you think you'll be changing before you test it again? My personal favorite is 1, okay? I might go all the way to about 10, but not more than that, okay? If I make more than 10 lines of code and then I test it and something is broken, I have to find out which line out of the 10 lines of code is responsible for it. Okay, so that's why it's not a good idea to put all the lines of code into one single source file. Are we doing okay so far? Okay, for your homework assignments, it's a different story, okay? How many lines of code do you think you can expect to write not only in this class, but in any programming class that you'll be taking here or in a 4-year university? Just give me an estimate.
Just like a total?
Sorry?
A total or like per assignment?
Per assignment. So each assignment.
Maybe like 100, 200.
Well, sometimes the projects can go a little bit beyond that.
Yeah.
I would say at the most maybe 2,000 lines of code. And when you're taking those classes as a student, you would look at 2,000 lines of code and go like, that's a lot. man, I can't, I can barely deal with it. Well, think about this. 2,000 lines of code is what is the percentage out of 10 million lines of code? Not a whole lot. Not a whole lot. Okay? So you kind of have to put everything in perspective. So what seems obvious to you, which is I want to put every single line of code inside one file so it's easy to manage, it doesn't scale up. That approach does not scale up. Okay? But why do I have to talk about this? I have to talk about it because I want to explain to you the compiler, which is G++ with a -C option, is only responsible to translate one source file into its object file. If you break up your source code into 200 files, if the other 199 source files are basically unprocessed. They remain as is. Okay? If they already have object files created, those object files will also remain as is. Okay, there's an easy way to look at this. Okay, how many people read manga or something that is translated? Okay, manga. Okay, so imagine this. Okay, you have a really long manga. Okay, like Nausicaa. Okay, Valley of Wind. So that's a really big multi-volume type of manga. You don't want to use one single book for the entire manga, so they divide it into what? Volumes, right? Okay, so you can kind of imagine one volume is one file, one source file. This is the Japanese version. This is the English version. Okay, it's that easy. Then what do we do next? How do we get the program to compile, to run? In other words, when you're ready to publish, there are things you need to do. It's called linking. Now, linking is using G++ again, but this time using slightly different options. Use a -O to specify the output file. So the name of the executable is what you want to specify right after -O. My usual convention is just using the name of the program without any extension, main. But this is up to you. Okay, if you want to name this main.out, that's fine. If you want to use a DOS option of using .main.exe, that's fine as well. I personally just use main without any extension. And then what you do is to specify, this executable relies on these object files. But in this case, since I only have one source file, there's only one object file to specify. And you press the Enter key, that will compile, that will link, not compile, this is going to link the object files into one single executable. Yes?
How would you separate multiple object files? Do you have comma or space?
Nope. You just say, file 1.0, file 2.0, just space.
Okay.
The space character can separate all the object files. But since I only have one, that's sufficient. Yes?
How does it know what relation to order?
Say again?
How does it know what relation to order?
How does it know?
So if you have multiple files that are, so say you break up a piece of source code.
Right.
How does it know what order to put those parts back into?
It will use the order that you specify on this command. So whatever order you specify here, it will try to use that order. The main job of the linker is to resolve unresolved references across the files. In other words, in one particular source file, you may have a reference to something that is defined in another file. Okay, so the compiler doesn't really care. The compiler will just insert a stub and go like, this is unresolved, to be resolved later. It is up to the linker to actually resolve that. Imagine this in a manga, okay? In the Japanese version of a manga, maybe on a certain page, there's a footnote and say, refer to your volume, blah, 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 page, blah, 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 for an explanation of this concept. Okay, so it's a reference to something else. But the page number can get shuffled a little bit differently in the translation process. So the compiler, which is the translator, is not responsible to find out the exact page number. Someone else will have to look through all of the volumes, before publication, so that all of these unresolved references will be resolved. So is that kind of answering that question a little bit? Okay. Go ahead.
Backtrack a little bit. How did you get out of V to that screen?
VI?
Yeah.
To to get out of VI, you can use :X to save and exit at the same time, or WQ, would do the same thing. Yes.
Is this type of writing and code information we're supposed to learn from previous programming classes?
Could you ask that question again?
Is this type of writing that's on the display?
Yes.
Is this type of code information we were supposed to learn from our previous programming class?
No, these are all command line commands. Okay, so this is something that is new to you, but this will be useful for those of you who are going on to cisp310. You'll be seeing pretty much the same thing in cisp310. These are basically Linux commands, but some of these are specific to programming. All right. So let's go ahead and check out some stuff again. We'll list the content of this folder, and you can see that we have 3 files now. We have the source file, okay, a single chapter of manga in Japanese. We have main.o, which is a single chapter of manga, but translated into English. Now remember, this can contain unresolved references. In other words, it can contain things like there's a little post-it that says, okay, on here, on this page, we need to refer to the whatever page number that this particular character first appeared. Okay, but it's not resolved yet. Once everything is resolved, then it becomes the executable. So we go from the source file, main.cpp, to main.o using the compiler, the translator. Then we go from the object file to the executable using the linker. Now, in this case, it's a little bit confusing because both the compiler and the linker are G++. Are we still doing okay so far at this point? Yep.
This what you did the LS for? What's the LS?
LS is list content, so it shows me the content of this folder, of whatever folder I'm
That
in.
would show you like any mistakes that.
No, it just shows me what file I have in this folder. That's all. All right. Yep, go ahead.
For our assignment, do you prefer us using either a standard input output or input output stream, or is it just?
That will come later. Right now, we are not concerned about that. Yep. Any other questions? Are we ready to run this program? I mean, after all of these steps, are we ready to run the program? Sure we are. To run the program, you cannot just say main. You have in Linux, you have to say /main. Because if you say main, it will say, okay, I will go to the standard paths of finding executables to find main. And main is not there. To emphasize that main is in the current folder, you use /. Can anyone guess what a single dot means in Linux in the command line?
Which drive you're using?
Nope, it means here in the current working directory. The dot means the current working directory. So /main means I need the main executable in the working directory. I want to run it. Okay. Now we can try to say main and see what happens. If I just say main and then press the enter key, it says it is not found because main is not one of the executables in the standard path, PATH, in the system. And that's why it cannot find it. On the other hand, if you say, don't search in those directories, just look in the current working directory, then it surely is in the working directory. And that's why you have to say // and then the name of the executable. Are we still doing okay so far with this exercise? Okay, and I'm just going to double check the recorder because I want to make sure that it is still recording because this is probably important. All right. Yes, go ahead.
Can you elaborate on what you mean by standard path a little more, like why it is?
Okay, I can explain that just fine. Okay, so let me just give you. Okay, what I did was I just run a single command to show you what we call the system path. And by the way, this concept exists in Windows as well. Okay, in Windows there is a system variable called path. Now, when you look at this here, okay, they are all separated by colons. In Windows, it will be separated by semicolons. Okay, but it's the same concept. we have one folder called /usr/local/bin, another folder called /usr/bin. The third one is /bin itself. The fourth one is /usr local games, and then /usr games. Go ahead. Ah, good. Thank you for the reminder. There you go. Okay, so the system path is basically, yeah, go ahead.
So just to see if I have it right, if you move main up to the same level as /user run /main.
Yep, then you'll be able to find it. Because what, if you just say main without any specification of where to find it, then it will first go to user local bin to find it. Failing that, it will go to /user/bin. Failing that, it will move on to the next one and so on. So that's why if you just type main and press the enter key, it cannot find the command because it's not in any one of those 1, 2, 3, 4, 5 folders. Now you can adjust path to include the current working directory, but it's probably not a good idea because usually people do not do it. So you just have to say /main to run the command, to run the program that we have just created. Are we doing okay so far with this? If there are no questions, I'm going to finish my own programming assignment because remember it's supposed to say tax world rocks, right? So what do I need to do to change this program so that instead of printing just the usual hello world, it will say tax world rocks? Go back to which file? There are 3 files right now. Which file do I go back to change? The CPP file, okay, the source file. Everything starts with the source file. Okay, very good. So this time I'm going to use Nano, which is a different editor, just to show you what it looks like. So Nano main.cpp, and this one automatically has syntax highlighting, which is kind of nice. And what I need to do is to move the cursor to the place where I need to make some changes. Tax world rocks, exclamation point. And this one is pretty much the same key binding, or you use the same keys as in Notepad. But if you want to do something like how do we get out, how do we exit? Well, let's see. Exit is right here. Okay, so we know this $X somehow has something to do with exiting. The caret symbol means control. Okay, the control key on the keyboard. So $X means press Control X to exit. Caret uppercase O, here, right here. It says write out, but that's really just for saving the file. Okay, it's just using some awkward wording to mean the same thing. Control W, which is this one here, is where it is. I think it's search, but we'll give it a try. Yeah, that's search. Okay, so for the most part, it's easy to learn because you can actually look at the bottom part of the editor and actually find out, okay, what control key do I use for what? Okay, so in this case, I have done my changes already. I press Control O to save the file. When you press Control O, it will double check and make sure, do you want to write back to main.cpp? Yes, that's what I want to do. And then after that, I can exit, which is Control X. So press Control X on the keyboard and we get out of the editor. It is a lot easier to learn compared to VI, but once again, VI has a better longevity because it has been used in just about any type of Unix/Linux system. So in the long run, it is worth the time to invest into learning VI, but it depends on whether your path is in computer science or in some of the other areas where you don't have to learn VI anymore. Okay, what do I do next? Yep, go ahead.
If you know VIM, do you know VI?
Yes, VIM stands for VI improved. So it is a superset of everything the VI can do. Okay, very good. Good question. So what do I do next? Oh, maybe it will change now if I just say do a /main. Would that work? That won't work. Okay. So in order to understand why this is not going to work, I'm going to use an ls, but this time it's not just ls by itself. It is ls-l. Okay, which stands for long format. In other words, I am now listing not just the files, but I also want to find out when each file was last modified. Okay, and you can now see main.cpp was last modified at basically 8:48. The system clock is off because it's not using the right time zone. Okay, but that part is not important. But this one, so main.cpp is more recent than the other two files. Is that obvious to you? Okay, so where's the problem? The Japanese source of the manga has been updated. What about the translated chapter?
Nope.
It's not. It's outdated, right? What about the publication itself? It's also outdated. So now we have to repeat those two commands that we ran earlier. In other words, first of all, we have to use a g++ -g-1 all -pedantic -c main.cpp to compile or translate it from source code to object code again. Once we have that, you can see from ls-l, now we have an updated object file, but the executable itself is outdated. That's the second step we have to do, is to relink the object file into the executable. So we say g++-o main.c, oh, I got the wrong one, main.o, press the enter key, and then do another ls-l, and now we have everything updated. The source file should be the oldest, the object file the second oldest, and then the executable the most recent. Yep.
Can you do the compiling and the linking together since it's using the same?
Yes, you can. In fact, you can. You can use the up arrow key to go back to a previous command. If you cannot remember or is really way in the past, there's another command that can be helpful. It's called history. Now, history is really helpful because it shows you all of the commands that you have typed up to this point. So if you just want to repeat a certain command, let's say we want to repeat the echo path command, which is 82, what you do is you type exclamation point 82, and it will just basically repeat that particular command, which is really handy. Yep. The exclamation point is a special symbol that tells the command line interface that I want to do something with history. So you can specify a number next to the exclamation point. It goes straight back to that particular command that you want to retrieve. Or you can also use something like this. If you use the exclamation point and then a part of a particular beginning of a command, it will go back into the history and retrieve the first match going backward in time. So they're really kind of handy stuff to learn. I mean, this is not a class about Linux command line, but these are kind of nifty things that I have learned over time. Yep.
Do you compile and link at the same time? Does it output two files or just the one?
It will only do one. It will only output one file. You can do that, but it's a bad habit. If you compile and link in one single command, you can do it, but it's a bad habit because you're merging two steps into one, and eventually you will still have to break up those two parts. It's okay in this class. Okay, I cannot check whether you combine both commands into one or not, but it's good to kind of keep it in your mind. Conceptually, there are two steps. Okay. Any other questions? Well, I made some changes to the source file. I recompiled, I relinked, so it's time to run the program again just to see whether it is running correctly. So, and it does work. So I'm done with this program. It's time to turn it in. To turn it in, you have to use that really long tar command, the similar command to the one that you have to use to turn in the homework that's due on Wednesday. So we say tar czvf. And then the name of the file is a tilde symbol / in this case it's going to be world_done.tar.gz, and then the other part would be -c backtick pwd backtick. Okay, but it's helpful if I explain this command so that you guys can actually see, oh, okay, so this part means that part means the other means what. The first lowercase c means create. Okay, so tar can be used to extract, test, and create. And this is specifying I want to create a new tar file, which is an archive. Z means, I want to compress the file. There are two ways to compress files that are built into tar. One is using the gunzip or gzip utility program. The other one is to use the bzip2 program. Z specifies the gzip program. V is verbose, so it will list the files that are being compressed and included into the archive. F means, give me the name of the file, okay, the name of the archive file, which is exactly this part here. The tilde symbol means home folder, okay, but that refers to all the way back to the home folder. Slash is a separator, so you can separate folders and files in the path. World.done.tar.gz is the name that you have to save to, so don't save it to any other name because otherwise my script won't be able to pick it up when it's reading it. There's a space here. Dash uppercase C means, oh, I forgot one slash, didn't I? There's one slash right after the uppercase C and separated by space characters. So dash C, slash is basically saying, okay, when we are compressing or creating the archive, look at things from the perspective of the root folder, the very root folder, which is a single slash. And then backtick PWD means use the output of PWD as the actual path of where to find the files to compress. The source, okay? Where are we including the files into the tar file, into the archive? So that's the full explanation of this particular command. You press the enter key. The warning message, not error, the warning message that you will get is removing leading slash from member names. That's okay, okay? It is not an error message, it's just a warning message. But then you can see, all the stuff that is being included into the archive file. Where's the archive file? Hey, where did it go? It's not here.
It's in the directory above this one.
Exactly, because where did I specify? I specified the tilde symbol here. Okay, the tilde symbol is going back to the root or the top part of a user folder or the user directory. So if you go back to one folder above world, and just I have too much junk here, so I'm just gonna specify the one that I want to use, and it is here. So this is the file that you have to turn in. Are there any questions about this particular homework assignment? Now, I know it looks really simple, just a few steps, but give yourself enough time to do it, because if you mistype something, it's not going to work. Yep.
When does this video get uploaded?
This video will be uploaded, when I get home as soon as possible. So it'll be up by 4 o'clock at the latest.
And when is this due?
Oh, okay. Well, that's a very good question. It's legitimate. So I'm going to give you guys a week to do it, or close to a week to do it. So let me change the due date to the 9th. Oops, no, that'll be more than a week. Today is the 31st, so I'll give you up to the 7th.
You should change the cutoff date too.
Changed what?
Cutoff date.
The cutoff date is not specified. Yeah, so it's okay.
Yeah, you need to be enabled.
Yeah, it's not enabled, which basically means all the late submission will be appearing in red. So when I grade it, I know which one is late. Yep.
Are most or all of our homework assignments going to be turned in with the .gz?
Yep.
Okay.
Yep.
Because I turned in the wrong one.
Yeah. Once you get used to it, this is how we turn in all the homework assignments for this class. Are there any other questions? Yes.
Get a weird error when I try to rip a file. Does that write that wrong file?
That usually means you forgot your PWD is not right. You did not use the backtick with PWD to circle the PWD. I'll point out which part. It's probably this part here. It's enclosed by the back quote symbol. All right, any other questions? How about reading assignments? Have you guys been reading this stuff online? Remember, this class is hybrid which means we are only doing one part here, and then the other part you have to do kind of on your own. Yep, go ahead.
So the quiz we had that was today, was that information on the quiz from the reading material online?
Well, I just sent an email to all of you today, which is we are moving on to expressions. So as far as reading is concerned, you should be done with getting started, and we are starting on expressions this particular week. Yep.
Two things. I completed that quasi quiz thing.
Okay.
And
in getting started, or
in getting started, it didn't get to tell me though my score. It didn't tell me if I actually.
If you
got
want
the
to know your
answers
score,
right.
you can go to your grade book.
Oh, okay.
Yeah, when you go to your grade book, it will tell you your actual score.
Okay. One other thing you want me to ask you later. I put in my virtual machine and try and connect to WinSCP, and when I try and transfer the tar file, the GZ file, I get an error 3 permission denied. I've already
is weird.
looked for fixes and tried settings. It might be a permissions thing. I'm not sure.
Are you moving from the virtual machine into Windows?
I'm moving from a downloads folder on my native operating system to the virtual machine.
You may be moving it to some folder that you do not have permission.
I'm moving it to home.
Is it the home of the user? Okay, I have to see it to see that. Okay.
Okay.
So anyway, this homework, setting up a Linux environment for homework assignments, is due on Wednesday. This one, Your World Rocks, is due next Monday. Okay, so those two definitely have due dates. But we are moving on to basic syntax, expressions, and operators. Okay, so this is where we are going to be focusing our discussion. Once again, we have a forum, basically a discussion forum, that is specifically for this particular topic. Okay, so if you read the content and you have questions about the content, this is where you post and ask questions. Okay, you can come to my office hour as well. Okay, but this is one really good place for you guys to ask questions and also to answer questions from other people. Question? No, I thought you had a question. All right, the grayed out stuff you cannot see because they have been updated. These two are not actually quizzes, okay? Because they're really open. You can take whatever amount of time it will take to answer these questions. The other ones I have not converted into quizzes yet, so they are still regular HTML pages. But you basically have to kind of read it in this particular sequence, okay? It looks like a lot, but it's not, because some of these are kind of short. They're not really long. Like this one is really short, the modulus operator. Okay, that's really short, right? But some of these are longer. Okay, so the ternary operator is a little bit longer because there are more examples involved here. And then there are some that may be a little bit harder to understand as well. Okay, I can give you an example of something that is difficult to understand, or difficult to actually, not understand, but difficult to absorb. Okay, comma is an operator. It is not a separator. It is an operator. Okay, so now you have to kind of think about, but what is the difference between a separator and an operator? Well, give me an example of an operator that we use all the time. How about plus, right? What is that? Come on, just use your common sense. It's not a trick question, not yet. Okay, what is this?
3 plus 7.
Give me the answer. 10. Okay, very good. 10. Okay. 10 is a value, isn't it? So with an operator, it always gives you a value. Okay? Hold on a second here. Tack, you just said that comma is an operator. That doesn't seem to make a lot of sense, because if I give you 2,7, it says, hey, this will give me a value as well. But if you read the notes, you know which one it will give. It will give you the value of the last thing of the comma separated list. In this case, 7 is the last one. Guess what? 7 is the value of this whole thing. Is that making any sense so far? Are you guys ready for more confusion? Well, let's try more confusion. What about this? See? I told you that comma gives you a value, but I never told you anything about the associativity of a comma. In other words, is it grouped like this, or does it group the other way? What do you think? What is the normal way? What is the common sense way of grouping commas? It is left associative. In other words, this expression is the same thing as 5, 7 in parentheses, comma 10, the whole thing in parentheses, comma 2. Okay? So what is the value of this entire thing? Just, if you look at this whole thing as an expression, what is the value? What is the last thing that we do? Which comma is the last one that we do? 2. Okay, which one do we do first? Which expression do we deal with first?
5 and 7.
5 and 7, because they are the innermost in parentheses, aren't they? So 5, 7 would give us what? 7, okay. The next one is going to be 7, comma 10, and that will give me what? 10. And then the very last one is 10, comma 2, and that will give me what? 2, exactly. So 2 is the answer of this particular expression. Once again, it is an expression, it is not a list. Okay, comma is an operator. So that's why, those are the little things that can get you. Okay, in C and C++, you have to read the text very carefully. Okay, if you have questions, okay, you can ask me. You can also design small experiments in the program in C++, and try to see if you can prove yourself right or wrong. Okay, that is actually a very useful process. Okay, you look at something, you go like, okay, I am interpreting this as X, Y, and Z. Okay, I think that's what it means. How do you know that's right? Well, write a small program to test it. Okay, because that will let you exercise all the tools that we have talked about today. Okay, all the command line stuff that we have talked about today. It will also help you exercise your mind of questioning yourself, but in a much more in a critical way and a logical way. And those things are what you need in order to become a successful developer, a successful computer scientist. Are there any questions at this point of what you're supposed to be reading at this point? No questions? Okay. Yep, go ahead.
Okay, so I'm saying those are all the reading material for the section right now. The first one with the NAND logic gates. Was there any reading material that posted, or was that just?
That's just an introduction, because we are just talking about at the very lowest level what are computers made out of. Well, they're all transistors, and they can only deal with zeros and ones. But out of those, we have logic gates, and out of the logic gates, we can design bigger components like the processor. But the processor only understands machine code, which is really, really hard for people to deal with, and that's why we have high-level programming languages. But they need to be compiled and linked in order to become an executable, where the program can be, where the computer can execute a program. All right. Any other questions? I'll give you another tip, okay? Because this one, somebody is going to fall on this one as well. Because in many other classes, especially Visual Basic, assignment is not an operator. Okay? So in a programming class, most people look at this and go like, we know what it does, right? What does it do? Does it test and tell you whether X actually has a value of 20, which is what a mathematician would do? Or does it change X as a variable so that it becomes 20?
It changes X as a variable. It changes X.
It's an assignment operation, right? But in Visual Basic and Pascal, in a few other programming languages, this is a statement, okay? This is a statement. It cannot be used as a part of another expression. It has to be standalone. The one line can only do this all by itself. Not in C. In C, you can do something like this. You can say X equals 5, putting in parentheses plus 8, this whole thing, this is Y, And this one is, I just use extra parentheses here. They're not really required, but I use extra parentheses to emphasize the ordering of these operations. That you can see, you can do in C++. Because assignment is not a statement, it is an operator. In other words, it has a value, just like what we showed earlier. Remember, 3 plus 7 has a value of 10. Assignment has a value as well. So I'll just give you a quick rundown of what this is going to do. Which operation is the innermost? X equals 5. Okay. So x equals 5 is the first thing we do. X equals 5 will actually change x so it becomes 5. That is what it does. Okay. But in addition to that, this expression, x equals 5, has a value of the right-hand side of the assignment operator. So it is actually 5. Okay? 5 is the value of the expression. And that's independent of changing variable x to 5. So you have to understand that part, okay? It does two things. Okay, now we have 5, we have 8, there's a plus operator here. That one we know for sure. 5 plus 8 is 13. What do we do with 13? Put it in y. Okay, so y is now updated to 13. And on top of that, what would this particular assignment operator do? It gives us a value, but what value are we dealing with here? 13, exactly. It's the right-hand side of the assignment operation. So when you look at this entire thing, it has a value of 13. What do we do with this 13? A value of 13. We add that 13. Well, we subtract 5 from that 13, and we get back 8, right? So when you look at this entire thing, we have a value of 8, and z is updated to 8 as a result. Okay? This is why, just talking about operators will take this many slides. Now, there's also a ternary operator that is also completely missing in many programming languages. A ternary operator means instead of having 2 components or 2 sides, it has 3. Yep.
I was just thinking, even though it's syntactically correct, just moving forward, keeping it in mind, would you say that I probably want to avoid doing something like that, though, just for diagnosing the code afterwards?
You just pointed out something that is really true, okay? And you should remember this. Just because you can do it doesn't mean it's a good idea, okay? Now, C is not the worst programming language for that, though. Okay, if you want something like this, you want to use Perl, because they actually have annual competitions of who can write the most obfuscated code that just do something that is rather simple to begin with. Okay, so yes, you are absolutely right. Just because you can do it doesn't mean it is a good idea to do it. Okay, but why do we have to talk about it when it is not such a good idea to do something like this, but it can be done? Why do I talk about it in a beginning class like this?
Because sometimes it's a good idea.
Sometimes it's a good idea. Now, just because you know this is not a good idea and you don't do it, doesn't mean other people will not do it like this, right? So imagine what are you going to do when you first get hired as a developer or as a software engineer? You get to write your own code.
Work with a team.
You work as a team. Well, it's more like you are the support person. Okay, when they report in, okay, there's a bug. This program doesn't work the way it's supposed to. Guess what? You are the person who's going to track down where the bug is and fix it. Okay. In other words, you'll be reading the source code written by other people. You're not going to write anything new. You'll be fixing the code of somebody else, which also means that person who wrote that code that is broken might write something like this. In other words, you have to know how to read it. Even if you're not going to write any program like this, you still need to understand what it means when the code looks like this. Yes?
Would you say the majority of software development entry-level jobs are just bug breakers?
They use it as a test, for new employees. This is a really good test because people who feel debugging is boring, debugging is pointless, they can go look for another job. Okay? People who give up because it's too hard, they can look for another job. Okay? people who can prove themselves by actually debugging programs, finding out where the flaw is, they are getting familiarized with the source code, which is great, okay? And the second thing is they have also demonstrated they have the patience, they have a logical mind, they can solve problems, they have all the qualities that are actually needed to become a successful software engineer. And that's why a lot of times, the first few jobs or the first few assignments of a new developer is really just to fix old bugs. I mean, because that's a really good test. Are there any other questions about what we are supposed to be doing this week? Yes, go ahead.
When you went through the rundown of writing, I'm guessing it was C plus language to create the hello world output, were we just supposed to be parroting what you were doing, or were we supposed to already know that syntax?
No, you're just looking at what I'm doing here and go like, oh, whatever is in the double quotes is printed,
Okay.
just change that portion.
Yeah.
We are not quite to the point where we can construct programs yet. Okay, so we are just getting stuck with that first. That really is nothing other than getting you through the process of editing, compiling, linking, and running, and then turning in the files. Yep.
I kind of have an off-topic question.
Well, if it's still related to the class.
Yeah. What would be your opinion on teaching as an introductory programming course C++ versus Python?
That's a good question. C++ definitely has a few more steps, and Python, being an interpreted programming language, is interactive. You can actually, quote unquote, run a program, as you're writing it. In Python, there are no open and closed curly braces, and indentation becomes kind of more important. So it's kind of a toss-off, between those two. But I can tell you one thing: Python is a scripting language. So in the real world out there, they expect people to be able to pick up Python by themselves without going through classes. C++ is a fairly industry-recognized language used by a lot of companies. So that's the one that they use, for not only here, but also for most of the UCs and most of the CSUs also assume by the time you transfer that you know how to program in C++ with proficiency. Yep.
If Python is easier to pick up, and because it's a scripting language, why are companies paying high top dollar for Python programmers if it's such an easy thing to add on to your arsenal?
Well, as a programming language, Python is easy. But what makes Python powerful are the libraries that get stacked on it. So they're not paying the top dollars for the knowledge of the programming language itself, which is actually simpler than C++, but they're paying the top dollars for the knowledge of knowing which library to use when. And that's because the library is a big thing with Python, is a big thing. With PHP, it's kind of a big thing. With Java, it's definitely a big thing.
And the library is just code that other software developers have created
Correct.
That adds functionality, kind of like gluing and pasting different code.
They're basically modules that you can just bring in and utilize. And that really is important because you don't want to reinvent the wheel when somebody else has already done it. So knowing what is already available is a big part of being efficient. All right, good, very good questions. I like it. All right, so we are going to end today's class. I will upload before 4 o'clock. If I don't, send an email to me and remind me because there's a lot of useful stuff today. And thank you for bringing the chairs back here.